Hey guys, today we're solving Leetcode 1249. Minimum remove to make valid parentheses. We're basically given a string with opening and closing parentheses and lowercase English characters, and we want to return a string with the minimum number of characters removed to make that string valid. So we've got three conditions to ensure a string is valid. Basically if it's empty or only has characters in it, it's fine. Any two strings added together that are both valid are a valid string, and any valid string wrapped in parentheses is valid. So at a high level, we can approach this problem by iterating through the string and keeping track of how many opening and closing parentheses we have. And at the end, we just want to know the indexes of the characters to remove from the string, and then we can just remove those characters from the string and return that string. So since we want to remove the minimum number of characters, we don't ever need to remove any lowercase characters. We should only need to remove parentheses. And we can sort of see that if we have a closing parenthesis without a corresponding opening parenthesis, then we need to remove that parenthesis. And if we have any opening parentheses that don't have matching closing parentheses, we would need to remove those opening parentheses. So, in example 1, the first two parentheses match with these two closing parentheses, but the last closing parenthesis is not matched by an opening parenthesis. So we would potentially remove any of those three, but the way I'm thinking of doing it, we would remove the last one. Similarly, in example 2, we have this first parenthesis that's closing without a corresponding opening one, so we would remove that. And then in example 3, we've got two closing parentheses with no opening parentheses and two opening parentheses without closing parentheses, so we would remove all of them and return the empty string. So now we get to the implementation, and for this problem, we can use a stack to keep track of the opening and closing parentheses. In the case of Python, it's essentially just a list because you can append and pop, so it's kind of the same as the classic stack operator. And then we also want to keep track of the indices to remove. I'm going to do that using a set. Now we just have to iterate through the elements in S, so we can do ix and enumerate S. And then we have to check for a few different cases. So the first case is that we have an opening parenthesis, and the second case, the else, if we have a closing parenthesis. And if we have a lowercase English letter, so the else case here, we'll just ignore it. Now, if we have an opening parenthesis, we can just append the index for that character to our stack. And if we have a closing parenthesis, we have a few things we have to check. First, if the length of the stack is greater than 0, then all we have to do is pop the last opening parenthesis index from the stack and move on. But what if we run into a case where the stack's actually empty? Well, that means we don't have an opening parenthesis to match up with this closing parenthesis. So we're going to add our current index to the toRemove set in that case. Now, what if we reach the end of the problem and our stack's not empty? Well, that means we have opening parentheses that we haven't closed yet. So we're going to want to throw those into a set, and I'll call it temp. And we want to add those to our toRemove set, which we can do using the union operator like this. Now we've got our set of indices to remove, so all we have to do is create the string that we're going to return. And we can do that using Python's join functionality. We will essentially iterate over each index in S, and we will return s of I for I in range length S if I is not in toRemove. And I can go ahead and use the enumerate syntax I used above so that I don't have to reference s of I here. But that's just kind of stylistic. So let's go ahead and run this and see what we get. Well, it looks like we have a syntax error. I have to say if x equals a closing parenthesis there on line 8. Try it again. Okay, it's accepted. Let's try the remaining test cases. Also accepted. Let's try running it. Nice. It's accepted. So at a high level here, we are iterating over every index in S. So line 5 is kind of like big O of the length of S. And then if we look at each operation we perform, these are all constant times, so our for loop should run an O of length of S time, converting our stack to a set. If the stack, in the worst case, has every single index in S, then it could also be, like, theoretically, O of length of S. And then, I would stand to reason that line 14 could also take O of length of S time to merge these sets, and this line would also be O of length of S. So our time and space complexity should be the length of the input string. So there you have it. That is Leetcode 1249. There are a lot of other parenthesis questions you'll probably see on Leetcode, so we can probably go over some of those later as well and connect it back. Once you do enough of these questions, it's kind of like pattern matching. You'll become familiar enough to solve a lot of these. Sometimes it involved dynamic programming. In this particular case, kind of a greedy algorithm worked, which is nice, but in some cases these problems can be a little bit more complicated. So until next time, have a great day. If you have any other questions you want me to try solving, let me know in the comments below. Like and subscribe, it helps the algorithm, and have a great day.